Okay, 2011 AIME Form 1. This is problem 2. And it says in a rectangle ABCD, AB is 12, BC is 10. Points E and F lie inside rectangle ABCD so that BE is 9 and DF is 8. And we have all these parallel things. BE is parallel to DF. We have EF is parallel to AB. And the line BE intersects segment AD. So that means we'll see that. The length EF can be expressed in the form m square root of n minus p, where m, n, and p are positive integers, and n is not divisible by any square of any prime. So that means that we reduce this radical completely, bring out any perfect squares that we can. Find m plus n plus p. That's a mouthful, but let's look at this. We have a rectangle where AB and CD are of length 12, BC and AD are of length 10. So let's draw that. If I draw a really nice picture, it'll actually show this entire problem all the way out. So A, B, C, D. So that is 12, 10, 12, 10. We know these are right. We know that these are parallel, but we'll leave that for now. Okay, now, might take a while. It might take more than one try to draw this correctly, but here's the idea. BE is going to intersect AD, so if we extend out, it'll come through here. They give you that information. I don't think that that is actually an issue. So let me put a point here. This is going to be point E. And this length, BE, is 9. DF, and F is right here, and I'll let you know why I'm putting it where I'm putting it. DF, so that's F. And this is 8. And we are looking for, let's see, what color do I want? We're looking for this EF right here. I'll call it X. We're trying to find this value of X right here. And a few other things. I know that these are parallel. I know that these are all parallel. So this one is parallel with this one. Is parallel with this one. Okay, and what that gives me is a few things. I first know that by alternate interior angles, those angles are congruent, and these angles are congruent. And if I were to then use this, and actually, I know one other thing, these are actually congruent to the first pair of angles by alternate interior angles here. If I were to insert a parallelogram right here, I did this by sort of sliding over triangles, but this is a better way to show it. Okay, then I know that this measure right here is X. And because of how things work out, because of these angles, I know that this is supplementary, so I actually have a straight angle here, which means this. I have a right triangle that I'm going to highlight here in red. It's right because it comes into a corner of a rectangle. Okay. And let me draw this to the side so we can see it more clearly what this means for us. So here's my right triangle again. This length right here, well, since this is a parallelogram that I put in right here, this is 8. and the entire hypotenuse will be 9 plus 8, 17. This leg is 10, and this leg is 12 plus x, because 12 and these two sides are congruent. Opposite sides in a parallelogram are congruent. So I'll just do a little Pythagorean theorem to do sort of this a squared plus b squared equals c squared. So we have a squared plus 10 squared equals 17 squared. A squared is what we're going to try to find, then we can subtract 12 off. So a squared plus 100 is equal to, and let's look, 17 squared. That's going to be 170 plus 7 times that is 7, 119, so 289. And then subtract 100 from both sides, so I get a squared equals 189. Take the square root. We only care about the positive square root because we can't have a negative length. Reduce this down. That's what this not divisible by any square of any prime. So reduce this down, and this is 9 times, that's going to be 9 times 21. So this is 3 root 21. And remember, that's a. So if we go back and we're trying to find x, we know that 12 plus x is equal to 3 root 21. So x is equal to 3 root 21 minus 12. And now, let's see. So we have m, n, and p. It's in that format. So we do m plus n plus p, 3 plus 21 plus 12. That's going to be 2436. And I write that with 3 digits. 036 is how it will show up on the AIME.